the screen says, the slide says. So I am the one who moderates NIF Connect, and I have the opportunity and the honor of introducing you to NIF Connect as well. So if you're joining for the first time, or if you do not know what NIF Connect is, you're not part of the NIF Connect community, then this is my opportunity to inform you about NIF Connect. So NIF Connect initially was started out as a close-knit community only for NIF users. NIF is a product, so it was basically only for NIF users, people who were in day out using NIF, for their SOC operations, for managing their security, managing threats in their environment. Right, and trying to come up with new things, new ways to show our community, our tight-knit community, about the things that the new features, the new enhancements that we have. Then we realized that our community is growing because many of people were sharing this information, and people are really interested in cyber threat based issues. People were interested in detecting threats, not only on the offensive basis, but on the defensive basis as well. So we had a lot of inquiries, wherein we started promoting this in a very different manner. We opened our community to many people who are from colleges, who are from multiple other organizations. If you are interested in cybersecurity, in the offensive or defensive parameters, this is the community for you. We invite everyone and anyone. So many. We have a lot of people who come here and present on multiple aspects of cyber threat. So that is the whole story about NIF Connect, and we have a steadily growing community that is really interested, and we have a host of experts, industry experts, who come on to NIF Connect, and I really appreciate that. I like take this opportunity to thank them. They come on to NIF Connect and explain about the situation they face, the knowledge that they have, the ideas and ideologies that they use on a daily basis just to mitigate threats or detect threats, right? So really appreciate and thank them for that. Now, so that being said, I'd like to move on and tell people that this entire NIF Connect is being streamed live on YouTube. So in case you get disconnected and not able to reconnect back, you can quickly go on to youtube.com/NIFHQ, and you will be able to view this entire session as it happens, right? So we're streaming live on YouTube. So that's one of the things. Right, and as I mentioned, we have a host. As I mentioned, we have a host of people who like to come on to Connect, right? And they're part of now what's called the Connect Community Heroes. So what they do is they come on, they tell us about a particular cybersecurity issue, a threat, a possible way of detection, a possible way of looking at a particular threat in a different angle. Right, and we have a host of them that come in. So this is your opportunity as part of the community, right, to come up, write to us at connect@nif.8. Let us know, you can tell us your name, what background are you from, and what is the topic that you'd like to present. And rest assured, every presenter is provided with a 1,000 rupee gift voucher as soon as and when they present on NIF Connect. So that is one of the things that we do. You can, as I mentioned, join the ranks of all these great community heroes that we have over here. Everyone from PwC, NSDL, NSC, SCID, that is the Symbiosis Center of Information Technology, Qualys, vFeeds, Kaspersky, you name it, these people have been here. We also have internal community heroes that have presented from NIF as well, who on a daily basis are monitoring environments and learning and adapting and building on the technology that we have and presenting on that as well. So technology and knowledge partners as well, they have contributed to us heavily through the last year. 2019 was a great year where we had all of these people come in and in one form or another provide us with their intel, their know-how, or it contributed in terms of services, and enabled us to provide or to explain to the community as to how a particular threat can be detected, how are they using particular technologies to get things moving and rolling. So a big thanks to them as well. So without further ado, let me break down the agenda for you today. We have a great, great session lined up for you. Two very, what you say, seasoned veteran when it comes to, teaching, and when it comes to cyber threat intelligence and the knowledge behind that as well. So we start out with UEBA, that's User Entity Behavior Analytics, with Mukesh Yadav from the NIF team. She's a technical trainer here. Her session will last about 20 minutes. Where she'll be talking about UEBA. We are then followed by our featured presenter for the evening. We have Vaibhav Tole, who is from Syngenta, and he will be telling us, taking us beyond domain blacklisting, and he will give us a perspective from cyber threat intelligence. And his session will last for about 45 minutes. So a great session lined up, and it's just waiting and watching and understanding and learning, right? So without further ado, I'll move on to our first presenter, who is Mukesh Yadav. So now, just to give you a little background, Mukesh is the technical trainer with us. She has a host of experience in a whole lot of things, which when I go ahead and explain to you, you will realize that she is adept at many things. So Mukesh is a technical trainer at NIF. Her expertise lie in machine learning, sentiment analysis, neural network, data analytics, using Python and R programming, MATLAB programming, IoT, Android application development. Now, that's saying a mouthful, right, in itself. So, apart from all of this, she's a sports enthusiast. She's into swimming, table tennis, running, trekking, and marathons. She's also interested in music. So surprisingly, we have two people who are very interested in music presenting. Vaibhav as well is very interested in music. Obviously, he's a bit more proficient and he's taken a long time, but Mukesh is no less. She's interested in guitar, as well as she's recently started, drumming. So she's training under that as well. So without further ado, I will pass it on to Mukesh, who will take it forward and will lead this session.
Good evening, everyone. I welcome all to the NIF Connect. So this is the topic which I'm going to take today. That is the user entity and behavior analytics UEBA, and this is the part where I'll be telling you about the UEBA, the basics, and as well as I'll end it with the short demo presentation. And what you can do is like you can connect to the previous Connect meetup which we had done it last year, and at 5916, so you can know about the previous you can say the UEBA concepts which was introduced, as in now we have a lot more features and functions available to work with the analytics part. Okay, as it is a very important part of the any of the SIM tool. So for today's my agenda would be I'll start with the introduction to the machine learning, then about the classification of the machine learnings, then how we do machine learning at NIF, and then I'll start with what is UBA, and then with the UEBA, and then with the short demo. Okay, so now as you can see, what is machine learning? So once the name comes, by if you even if you don't know the actual definition, so you can just say we have lots of systems. Okay, and what you're doing is like you're making your system learn, and what are you giving them as an input is not the textual information. It can be in the form of like if it is in the domain of textual, audio, video, so you're giving input as audio, video, text. And here in the cyber security, you are getting information in the form of logs, so you are giving the log information to the machines. So the machine, as in like once I say machine, it's nothing but just a computer, where in the traditional program you used to take data and the program and make the computer learn based on the training set, and then you provide the test set, and the test set are nothing but which you classify them into some categories and give as an output. And output would be that the data which is received is categorized as malicious or not malicious, good or bad. So initially if you had seen, okay, so it is said as like you're making your machine learn based on some patterns which are found. So we can say the system has the ability to automatically learn and improve from the experience. That is like where you need to know the input which you are finding out, and you want to, without explicitly you can say programming, it has to predict what is going to happen or what is actually going on. So The one question is, do you have to train the machine? Yes, you have to train the machine, because you need to work with some inputs, and you're getting some inputs in the form of like already trained data. Okay, or it can be like without the trained data. Okay, so yes, you have to train the machine. Okay, so in the machine learning, as you can see in the diagram, in the traditional we have the data and the program, but what about the program is not capable enough to give an actual output. So machine learning, what it does is it takes the data as well as output together, and based on that it creates a program. So program is nothing but a model. So we need the best model which is going to help you find out the result in the form of for a particular scenario. Okay, so there are different types of ML algorithms which are required so that the computer can understand. Also, these programs are categorized into different you can say categories, and these categories are nothing but the classifications. So in the previous connect we had talked about the supervised and this unsupervised, but there is also a term called as semi supervised. It is also, you can say it as reinforcement learning. So I'll just give you a short description about what is supervised, unsupervised, so that you will get an idea what are they about. Supervised is something like, suppose you are in a classroom and there is a trainer and there are list of students. Okay, so the trainer has all the information with him or her in the form of, you can say, you have the textbook, and the students, they listen on, they make a note, and based on the test, means the exam, there are some questions. So based on the knowledge which they have received from the textbook, they give an answer. But what about the questions which are out of the textbook? So that is where supervised learning, they have data in, you can say, the trained set is there. Based on the trained set only, you provide the output. So you say it is also best in some use case scenarios, as in like some scenarios. Suppose supervised learning, you can have various algorithms in them. Then apart from that, just in case if you want to have a data which is very abundant and the categorization is too vast. Okay, so that falls under the category of unsupervised, where in the, suppose in a classroom, instead of the trainer you have the list of all students. Okay, and the students, they are not classified, they don't have some trainer to train them. Okay, so what students will do, they will do self learning. So based on the self learning, they'll identify they have to learn this concept, another concept, another concept, so that will be helpful. But what about the content which are like completely non, you can say, not matching with the test case scenario? Means you have a large data, and these are all categorized into based on the properties and the characteristics of the particular object. Suppose you have different objects in front of you. Suppose I have got a marker, I have got a wire, and I have got a mobile phone. Okay, so based on this you have three categories, means they are of different category, but you can make them into one category. Say these are all, you can say, electronic item apart from the marker. So you'll have to order. So that time you can easily say the next test subject is belonging to class electronic or class other plastic object. So that time it is useful. But if it is not matching from any of this categories, so that time it becomes difficult for the unsupervised. But again, supervised also gives a good output. But what about the accuracy given by the algorithm itself? So there are various techniques to identify or to find out the how best the system is giving the accurate result. So that time you can use the accuracy, the based on the number of counts, based on the precision, recall, or RC curves, and as well as, you can say, the probability based counting again. But the drawback of supervised and unsupervised, we cannot say drawback, but yeah, the more features can be provided by the semi supervised. What it will do, it will have the trained data, means where you have the labeled data, and in the unsupervised where you have the unlabeled data. Both of them are taken as the data sets, or you can say a dictionary or the corpus all together in the semi supervised, and it helps you to predict any activity into the environment. Okay, so these are the like classifications of ML. Now, how we do machine learning at NIF? At NIF, we aim at leveraging state of art of machine learning techniques so that we can give meaningful insights at our customer SOC teams. So SOC teams are like security operations center teams. So what are these meaningful insight? Means in the log we have a number of columns, and suppose which what is going on, means the user is doing some activity. So that is how you can say, okay, the user is logging to a device and doing some changes and then logging out. So that is like you can find out what's going on inside the environment. And we use mainly the unsupervised learning model like the clustering algorithm, anomaly detection. But we are moving ahead with the semi supervised learning where we are providing more advanced features. So like suppose if I just say we have the linear regression. Now with the linear regression, more advanced is the polynomial regression. Now more advanced is, you can say, like we have the support vector machines, or you can say naive based algorithm, or you can say clustering algorithm, or you can say hierarchical algorithm. Every algorithm is best in their own case scenarios. Okay, which one is giving the best accurate result in the cyber security? Okay, so these are, like you can say, in the semi supervised models which will be taking in the, you can say, the advanced demonstration. Now currently we are using and serving the following use cases, that is for the user entity behavior analytics, UEBA, bad IP detection model, and the DGA detections. For those who are new to what is DGA, so this is like domain generation algorithm detection. So I'll be telling you about what is DGA also. So this is how we do machine learning at LIF. Now again, coming back, what is UBA first of all? Okay, so everyone who has come for the training, yes, they have heard about that we provide UEBA, SOAR, and we can say machine learning. Yes, now all these machine learning algorithms are all the algorithms coming and giving the facility of artificial intelligence. So what is artificial intel? It will consist of all the machine learning algorithms together and making, connecting with different devices and features will make it into artificial intelligence. Again, like I said, machine learning algorithm like naive Bayes, or you can say neural network, deep belief network, are nothing but, you can say, the semi supervised algorithm. Apart from that, we have DQN, that is deep Q network, or DDPG, that is deep deterministic polygradient, or A3C, that is asynchronous advanced actor critic algorithm, NAFQ learning with normalized advanced functions. So these are like, they are following some space, like they are handling discrete data or continuous data. We are looking with the real time log information, so we want to work with the continuous growth of the data, as like continuous data which we are receiving at the SIM tool. So that's where we need the UBA. Okay, but again, what we want to do in the cybersecurity is the detection of the insider threat, target attack, financial fraud. Yes, you need to look into various business contexts. Then what solution it provides? We look at the patterns of human behavior, like it can be like apply the algorithms, apply some statistical analysis, then to, so that we can detect meaningful anomalies which are like, which can be a potential threat. Suppose if someone is logging in a firewall, can that be a potential threat or not? So you need to classify that activity of the user. Again, we focus on like what the user is doing. So it can be like if some app is launched, or network activity has happened, or there is any file access from, you can say, on the cloud or from the system. So we can say that UBA is close cousin of SIM. The features are provided related to the SIM, but with the analytics part where the machine learning algorithm is used. So again, why UBA is required? So we want to consider where current data security approaches have like they are falling apart, means what are their drawbacks, or what they are not considering, maybe smart applications, what activities, or you can say smart you can say malware attacks, or you can say smart attacker. Okay, so that's where everybody needs to know about the perimeter based security. So we can say hackers, they are like more smarter, clever. So what they do is like, main, we already know how they work. Okay, that is like entering through public access points, yes, definitely. But how they become undetectable is they come or make, you can say, different malware and the attack types. Like similarly, they can just send a form, or it can be a legitimate form which the person will feel, okay, now it looks like good, beautiful, and you can say it is coming from a trusted domain. Yes, so the person will go ahead and give the details, and that can proceed with the, you can say, lot of attacks. It can be network attack, it can be file attack. Now the hacker technique, not from the access points, you can say guessing of the password, or keystroke detection, or using phishing, or you can say SQL injection. And another would be insert specifically crafted malware. Okay, and the malware, once you say, is just a script of code which can be attached with the, you can say, with the audio video. It can be attached with nothing but just your HTML page. It can be attached with the image as well. Okay, so it flies below the radar, means they become undetected from the networking devices which are doing, giving you the security. It can can be stealthy stealing, it can be APTs, that is like advanced persistent threats, where the user is behaving as a actual, or you can say normal user, but actually the person is an attacker. And also the command and control ways the hacker can do, you can say detect, or you can say attack a particular area. And that's why you need UBA. But again, the question is like, what is the purpose of UBA? So that you can uncover information that indicates potential attack. Potential attack means any activity you need to classify them, so classification is very important. Again, you need some analytics tool so that you can understand that based on these activities, can it be classified as class A or class B, and that is coming from huge volume of log data. Again, we focus on the behavior of the system, not only the user but the behavior of the system, and actually actual persons using them. Now, how UBA to UEBA came into the market? So it came in the September 2015, and according to the Gartner, as there is technology growth and also there are like different fraud techniques, so UBA was, you can say, renamed to UEBA because the events are also taken into consideration. So what it includes, it include devices, okay, it includes applications, it includes servers, it includes data, and include anything which is having the IP address. Now, what is the difference between both of them? Again, as you can see on the screen, like on the left hand side, UBA was only focusing on the security, that is the theft of data, and the fraud, that is the use of the stolen information. And UEBA, not only this information, it focuses on the malicious and abusive behavior that went unnoticed by the existing security systems like SIM and the DLP. Now, UEBA software correlates with the, you can say, user activity, endpoints, applications, cloud, mobile, on-premises application, and the networks. So what UEBA you are doing? We are doing protecting against external threats as well as the insider threats. Now there are various features you can find it out. Now can you see with the UEBA, with the NIF, we use like the advanced directive, that is the ML directive, which is created specifically for doing the analytics. Now there is like DGA algorithm, that is domain generation algorithm, so that you can identify what are the various domains which are generated by the hackers. Now what is it? You want to establish communication between, using the command and control between the attacker and the hack network. What it will do? Detect and block the attacker CNC attempt. So that is what an SIM tool will do. And then can you see how DG algorithms are created? Is it easy to implement? Yes. It is difficult to block? Yes. Impossible to predict? Yes. Quickly modified? Yes. Because now you can directly say xyz.com. It is very easy to create. Again, you can quickly modify and change, rename your name. Again, you can, it is impossible to predict because you make it active for some amount of time before getting detected by the, you can say, scanners, you can say third party intelligent tool. You make the, you do the activity, make the virus, you can say malware, you can say spread, and then you can just close the domain itself. No one is going to detect you. So again, what does it consist of? It consists of time, and it is called as seed, that is the current date time. Again, it consists of the domain, that is the body generator that uses this timestamp. Then it has the set of top level domains. So if I just say top level domains, you have .com, .net, or .co.in, or you can say .ru, .net. So what DGA can use? It can use like data from the Twitter analytics. What is the latest top trend, technologies going on, or the hot listed word on which is on the market, or you can say hot listed word which has been searched on the Google search engine. So based on a combinations, words, characters, or you can say with the TLD as an extension, can be used. And there are like some of the DGA variants which you can see on the screen, that is the unknown Russian DGA. What it does, it consists of like 35 domains are generated, and it selects randomly 7 letters. Okay, the end point, or you can say the suffix, would be like .ru, as it is unknown Russian, so it can be unknown Indian DGA, so it would be the Indian domain. So again, suppose if I just say Mukesh Yadav .com, okay, so it can be, you can say that could be a unknown DGN because there is randomly 7 letters are selected and it is added. Again, can you see word based DGA variant? It consists, it's called as a unnamed malware, which was analyzed by the CrowdStrike 2013. What it does, it randomly chooses two English words from the list of already stored, you can say hard coded list. What it will do, it is going to generate 1 lakh combinations from just 300 words. So that's how it becomes difficult for the detection algorithm. So what it can do, suppose if I just say sorryfellows.net, or if I just say you can just say marchingmonth.net. So that is how it can create a word based combination, that is called as a malware, and it becomes difficult to identify because it may appear in many legitimate domain names also. Okay, so again we have the knickers. So it is called as, you can say, a backdoor malware. So it will randomly generate strings. Now what would be the size of the character? It can be 18 to 20 characters, and at the bottom it can have a like domains, like you can say dot mn or dot tv or dot in or dot com or dot pro. So that can be like, it will be harder for the law enforcement agencies to take down these domains, because they will say now they are from a very higher domain. Suppose there was one scenario, the operation tower, where it becomes so many rules, and you need to follow the local as well as the national agencies to get that particular domain downs, because you have to follow and go through list of all you can say procedures. Again we have the, you can say, Drydex DGA, that is it provides, now this was the malware breakout in the banking sector. What it does, it you know that we use lots of macros not only for the conferences, you create lots of, research papers, or you can say, so there are like lots of macros which are running at the back for showing some, you can say, working with some predefined template. So in Microsoft Office, what it does is like these macros consist of the code, and it is used to infect the systems. Okay, so there it consists of English word as well as the part of the word chosen from the list of some list of words, and it is given with some suffix, that is suppose dot me, or you can say dot mn. And then we have the Angler exploit kit. So it consists of randomly chosen character and digits under from .com. Okay, so that is the Angler exploit kit, so which can be used for exploitation. Again, can you see unknown d word based DGA? It is malware which is injected inside the SVC host. Means it is a randomly D word, which is of when once I say D word, it is of 32-bit integer, and you can have a maximum of, you can say, 4 million words which are generated. Means 4 million combinations of the domains can be generated, and these are converted to the hexadecimal format. Like, and given the suffix, you can just give it by the TLDs, that is a domain level names, like .com. So if I just say 12345 a69.com, so that is like, you can say, that can be like combination of n number of words and the characters. Then we have CISPA. So it is called as a stealthy botnet, which is mostly used in the video applications, like you can see the Skype. What it does is it randomly generates string of characters with n, or you can say n length, that is like varying length. Okay, so it becomes very difficult to identify. So what, wherever it is before, not with the TLDs, what are the characters or the names for the domains has to be checked. Okay, then we have the unknown penny code. Like, so this is you can say like a non-English domain name. It consists of some of the, you can say, words which are, you say, www.x yz.com. So these are the names which starts with some special character. Suppose if you can say www.aaa. Some extension, some name would be there. So that's why it can consist of some non-English domain names as well. So these are some of the DGA variants. So while doing any you can say programming, so these are the domains which has to be checked, not only the TLD but the contextual data as well. Now let's see the stages of the UBA. Now we have seen like what is you can say UBA and how it changed to UEBA. Now you can also see what would be the stages. So all the day-wise activity of the user, these are nothing but the day one, day two, day n activities are taken all together into the training logic, because you want to train our data. So train data is collected. Again, you accordingly a train model is created. Suppose if I'm using the kernel based support vector machine, so you want to identify if any pattern goes, you can say, in the circular, or you can say in a cyclic form. So the n number of models are created. Based on this, once the model is created, it is sent for the analyze, where the algorithm finds out which is giving the best accurate output. So based on that, you get the, after the analysis, it takes an input from the scoring logic, and that scoring logic comes from the today's activity done by the input. From the extreme right hand side, you can see the users. So from that, the user activities are given as some scores, means these scores are nothing but how much or where they have gone to which subsystem model, and based on that, that is also an input to the analysis. So now this will help the SOC team to find out, or you can say to take decision in short amount of time. Again, now you have the, you can say, trained model, you want to keep updating your trained model, so that's where it is coming into the unsupervised learning. You are retraining your model, so you are doing called as, you are adding whatever results you have got or into the already existing trained model. So that's why retraining is always required. Suppose if you know that smart car, Google smart car, okay, so it takes whatever environment it is taking, it is keep on adding to the its already trained model. So that's where you can say recurring neural network, or you can say recurring information is required, or you can say back propagation. So from the whatever the results which you get, not the error weights, but also the output is taken as an input uh, to the system. Now after this, let's just let me just give you a demo on like how you can see as in like work with this. So let me share you my screen. Okay, so similarly, if I just give you, okay, what would be the user anomaly? Okay, again, activity of a user. So in the screen, can you see the lots of the environment users which are connected, and the names are in the x-axis. On the y-axis, you can see the scores. Again, for this, what you're doing, okay, for the, suppose I have the first user, that is Margaret 42, and if I just say the score is like 6, now where it is coming from, you need to have some history. Yes, the user activity, on what all subsystem the user has gone to. Okay, the person has done some activity, and it was a part of authentication, and it was a part of administration. So this scoring is calculated, and this scoring is over here. So higher the scoring, you means to say that the user has done so many activities. Similarly, you can see now, if I just show you, and if I just show you and open this particular widget. Now this was for the anomaly detection. Similarly, for the ML also, you can just give for the, you can say, the user tracking is the function which is using, and you are taking the input as the user and the subsystem. Also, we want to do the analysis part, so we are taking the data from the actual trained model as well as the real time information, and it is doing the analysis. As you can see, ABC and the ABC, so these are nothing but the variables which are required, so that you can give the variables for analysis part, means two inputs which you are taking. Now we are displaying the information on the chart. So we are taking the primary key user, yes, we need user information, and we need the tracked anomaly that is coming from the ML directive. So here, that is why you can see the total count for the first user, Margaret 42. Again, can you see on the bottom, we have the score, that is dollar score, and x-axis and the y-axis labels are given. Now what context detail which you're providing is dollar user p key. It is the key which we use in the NIF query language, that it is going to fetch all the users from the data store, and it's going to provide it into the trained data. That is where we are storing the data in the, you can say, the get history information, that is the get history function. Again, we want to track the user, so user tracker is useful. And if you want to show the log history, so for that you use display all the users into the information. So that is how you're able to see all the users. Again, just in case if you want to see, okay, I want to display all the users for the information which you are getting from, that is the user information from, you can say, tracked anomaly behavior. So if you just see, so for the same widget itself, if you want to display this data, like what user tracker information which we are getting, so you can just say that I want to display ML user information. So let me just take the same and let me show you. As this is a small demonstration of how you can work with the UEBA with the NIF. So for that, ML directive and the function. So similarly, let me show you for the first output. We have the list of all the users along with the subsystems which they have like found on. Again, in the second output, one, in the ML director, it will go to the user is being going to be tracked. Okay, now that user is going to be tracked on, that is the tracked anomaly which is walking behind the, you can say, user tracker function, and the number of times you can have found it as, you can they see the scores is assigned. Again, if you want to see the user history, so you can also provide the user history instead of the tracker, and you can see that the person has found it out. So this is like a very basic way, so that you can see the analytics done on the, you can say, using the NFSIM tool. And accordingly you can work on, you can say, various anomalies. Even if it is related to the user has done any, you can say, any activity, so that can be attacked. Even if you have plugged into the USB device or plugged into any system, and that is all there. Okay, now I would now this is like the end of the session for my for the UEBA. Now this is part one. In the part two, it would be completely you can say demonstrative about how you can do the UEBA analytics and detection, and raising the alert, and sending reports and everything. So also what you can do is, like, if there's any questions, so you can put it on the Q&A section. And do watch this previous video as well, as who have missed out, so you can watch this video also, and it was held at, yes, the last year at 5916. So that's all for today. And thank you everyone for patiently listening to the NIF Connect.
Hey, Mukesh, thank you very much for that enlightening session on user entity behavior analytics. So we received a query in the middle, like twice or thrice, actually. I think it's thrice. Yeah, that people had requested for UEBA and the details about the same. We had initially done something around that, and it was Sanket Shah, previous one of our previous people who had presented on UEBA and ML and an anomaly detection. So Mukesh has basis with the detailed information as to how this is done, and the procedures of the same. Part two, as he has mentioned, is going to be a full-on demo. So prior to that, obviously we'll put out necessary information for people to actually view this, the part one, and then step into part two, wherein it's going to be a full-on demonstration as to how one can use all of these capabilities. As I mentioned, and as Mukesh as well mentioned, it's very simple for you to ask questions. If you have any questions, just hit the Q&A tab down in the menu bar, and mention who the question is addressed to, and like it could be Mukesh hyphen and followed by the question, whatever the question is. Mukesh would be more than happy to answer them. Uh, That being said, yes. So we have a few awards that we'd like to mention. So the Social Geek Award is something that we provide to our dedicated NIF community members. So it's very simple way to win. Tweet on Twitter or post on Facebook using a hashtag NIF Connect and @NIF HQ, and you stand a chance of winning ₹1,000 Amazon gift voucher. It's as simple. So go ahead, go postal on the post on Twitter and Facebook. So another thing that we're very passionate about is building on the community and also contributing towards the community and understanding what the community members want and require. Right. So let's build a community of cybersecurity warriors. Right. How do we do that? We simply do that by maintaining, maintaining a list of feedback that the community members have for us. They can simply write to us at connect@nif.it and stack.nif.it and let us know their thoughts. How could we improve? What else do you want to see on NIF Connect? We've had, based on inputs, we've had a host of presenters, host of industry specialists when it comes to cybersecurity presenting on Connect. So please go ahead, write to us, and we are more than happy to include those suggestions into Connect. Yes, so now we move on into someone who is major cybersecurity and threat intelligence specialist now, Vaibhav Tole, and from Syngenta. Obviously, Vaibhav, I have been trying to get Vaibhav onto Connect, but because of his busy schedule, we were trying so many times last year, and wasn't happening. Wasn't The stars wasn't just aligning, the planets weren't aligned, and now we have it aligned, and we have him here. Okay, so just to give you a background about Vaibhav, right? He's a multifaceted person. He comes highly recommended by everyone here, most of the cyber, the fraternity as well. When it comes to cyber threat detection and intelligence, he is like really sought after. Now, just to give you an introduction, Vaibhav is the manager cyber threat intelligence and anti-cybercrime investigation as part of the global information security at Syngenta. He began his professional career as a developer and subsequently as a security researcher working on various security and compliance solutions at Symantec. He's also worked on security risk management and application security domain at DNY Mellon. Okay, professionally, has acquired the following security certifications. Now, bear with me: CEH, okay, CISA, CIRIS, CCISO, etc. Also, along with that, he's done his ISO 27001 LA and Prince 2 FNP. Okay, so that's saying a lot, right? And he actually schooled me on how do I say it as well. So now, apart from that, okay, this is not just it. Now, apart from that, he's from just being a security professional, Vaibhav is a qualified musician. As I mentioned, he's a pianist with a grade A piano solo from Trinity College of London. He's also a composer and owns a band named Rurr. If I pronounced that correctly as you wanted me to. So Rurr experiments with Indo jazz, fusion, and classical forms of music. So as you can see, this is the biggest introduction I've done for anyone, and he's quite talented, and it's an honor to have him here. And so he's going to present on what is going beyond domain blacklisting, a cyber threat intelligence perspective. So without further ado, I'm handing it over to Vaibhav. Please, who'll take it forward?
Well, a warm welcome to everyone, and thanks for taking time and tuning in to this particular DNIF Connect session. I'm really honored to speak on this session. Thanks all for joining in. So, today, I hope I am sounding better. I'm actually having a bad throat, but I'll try my best. So, today I will be presenting my views on the topic of cyber threat intelligence around domains. It's a small topic, right? Domains, and around a few innovative ways, basically some crude innovative ways to go beyond the traditional retrospective approaches, such as building blacklists. So that is why I have named it after a lot of thought, Beyond Blacklists. Before we go ahead, I just wanted to speak a few things. Uh, as I see today, while the overall domain of cyber threat monitoring, detection, and response has grown quite matured and commoditized, so as to say, it seems to be true for to some extent for CTI space as well, and it typically looks to be fairly rather majorly feed oriented, and that's all great. However, uh, I intend in my today's discussion to focus a bit more on infusing some crude or raw innovative aspects within in-house CTI functions, because I feel giving it a tailored treatment based on your organization's landscape, which could be in terms of business, IT, product portfolio, etc., etc., surely gives an edge and thereby more power to the key dear frontline security functions such as SOC, CSIRT, etc., to basically timely detect and remediate the hitting threats, and sometimes even to protect potential threats from getting materialized into major risks. And yes, while this is a relatively a huge subject in itself, and in interest of time, we may not be able to touch each and every nook and corner of it. That is what I feel. Let's try best to glance through some relevant key points on the topic today that offers much food for thought, and I hope that will be useful. Okay, so with this, just to set some right expectation around the scope and the way forward, let's go to the outline of today's presentation and discussion that I'll be speaking about. So we'll start with a very brief overview of what CTI is, what cyber threat intelligence is. Okay, we'll go into some kind of risky domain types, the variants of risky domains that could be there. of course, being used by malicious actors. We will then actually get into we'll try to actually magnify into one of the variants of domains which are risky domains. Those are known as typoscotting domains or typoscotted domains, which is the main music of the day. And basically, once we look into what typoscotting is all about, how what are the techniques to achieve typoscotting, we'll enter into some innovative aspect of CTI tactics. Now, CTI is a huge domain in itself. It could have multiple approaches. It depends upon your it's very dynamic in nature actually, and it all depends upon how your teams are laid out, what is your organizational structure, how risk tolerant you are, etc., etc. So basically, we will also try to infuse a lot of food for thought around the topic. The aim of this presentation is all about that, right? And once we are done with looking at a few CTI tactics that I shall be introducing, we'll look into some quick example workflows and a live demo on DNIF. And if we really reach there, we will call ourselves to be done. Cool. So let's move ahead directly into what cyber threat intelligence is. I'm not going much, or rather, I'll refrain from going much into traditional definitions, etc. However, I'll be just speaking, or I would like to speak about what I have learned so far in my professional journey, and I'm still learning, right? So, it's all about the ability to acquire and apply knowledge and skills in cyber threat space in general, so as to gather, filter, prioritize, and provide usable information. Now, usable is something very important. Usability of this information is extremely important, in my opinion, when it comes to pragmatic approach of this whole function, the CTI function. The information has to be usable, timely, and for whom? Basically, uh, one may say that it is for the SOC teams or the dear security frontliners like SOC, CSERT, etc. But it is not just for them. In my opinion, it is to help the business to augment its security defense in general. Because cyber threat intelligence is something that can be, I mean, it could give out a lot of information, not just for the SOC or CSERT, but can be used for investigations, for response, for a number of things. But from our security, traditional security, SecOps kind of model, it is definitely helpful for detection and response of threats. So basically, timely detection, timely response with minimum impact, and of course, some protection as well. Because I've kept this protection thing below with some intent. Basically, there is an assumption of breach in all organizations, all matured organizations, I would say, because incidents are bound to occur, right? Cyber space is like huge space. It has a number of possibilities, and incidents are bound to happen. However, the trick and the challenge lies in how fast you can detect it and respond to the threats, so that gradually you move towards protection. Because at times the themselves take time to actually proliferate and reach their end goal. So cyber threat intelligence actually is a key aspect which actually helps you going from detection to response to investigations, if at all there is an incident. Let's move to a very key aspect of cyber threat intelligence given by David Bianco's pyramid of pain. David Bianco, a security researcher, has proposed this model, which is really a good model, which actually gives us a degree of pain of problems that a hacker goes through if the defender knows or blocks these IOCs. So basically, this pyramid of pain actually, gives us certain artifacts that a CTI guy can collect and disseminate to his counterparts. It could be hash values, it could be IP addresses, it could be domain names, it could be network or host artifacts, it could be tools. Yes, tools being used by hackers. For example, if a hacker using, say, Mimikatz, okay, I can actually develop some kind of IOCs around that or some techniques to detect it within my network. Just for an example, the TTPs, tactics, techniques, procedures. Yes, the pyramid of pain actually gives me, as I go up the pyramid of pain, the pain increases. And the pain increases for whom? The pain increases for the adversary. In terms of, okay, so basically if I knew hash values for the hacker, it would be a bit trivial. okay, he can actually manipulate the hash values of the binaries and read through them, or read through those the binaries to me, and I can actually get trapped, right? I mean, this is a very simple scenario of what I'm speaking about, but yeah, in nutshell, it means the same. But for today's discussion, let's try to magnify the central part of this pyramid of pain, that is domain names. And the pyramid of pain suggests it is simple, right? It's very simple. But then it's simple for a hacker. If I knew the domain names, if I blocked the domain names, let's try out from CTI perspective to make it complex for the hacker, right? And that is the whole purpose of CTI, to actually block the threats, to protect, of course, to detect as well. So let's go ahead on these lines and have a quick check at what domains are and what are associated risks. We all know what are web domains actually, and when we talk about web domains, this is a very obvious word cloud that comes into our mind, which has DNS at its heart. So domain name system, we all know about this. I'm not going to go through the definitions, of course. That is why I've just given a random word cloud here, just to emphasize that, what exactly a domain brings along with it. So basically a DNS is at the heart of it. It has IP address to domain, or vice versa translation capabilities. A typical DNS record would have a record, a record which will have IPv6 addresses for that particular domain. String, basically it's a textual string that we can remember, but DNS actually translates it all for us so that we can reach the resource hidden behind the domain. And if I can do who is lookup for the domain, which gives me a lot of textual information, like, who was the registrant, who was the registrar, when was the domain registered. Say it gives me registry expiry date, creation date, domain status, X, Y, Z. And because of privacy reasons, at times this metadata is at times redacted as well. So we are seeing this a lot after advent of GDPR. However, this slide was just to emphasize the importance, or the fact that a domain in itself brings lot of metadata, textual metadata with it, and that metadata matters the most to a CTI analyst or a specialist, or even for the SOC analyst as well, when actually something happens or something has to be analyzed. So the metadata is important, is the gist of the slide. Let's go ahead to look into a few risk states that a domain could acquire. Now, a domain could be clean from CTI perspective. I mean, today something is clean. I go to google.com, it is absolutely clean. I can trust it. So basically, if I detect somebody in my proxy logs that somebody went to google.com, I may not be that much concerned because google.com is clean. Why is it clean? Because nobody knows what is going behind it. So I say it is clean. So it is all empirical, actually speaking. But until unless I actually get to know about some kind of an evidence or some kind of a news or some kind of feed around a domain which is really clean or malicious or suspicious, I actually would say it is clean, right? Otherwise, the business will stop. I'll block everything. So a domain could be clean, it could be suspicious. A suspicious domain would be a vulnerable or hijacked domain. So if I go to Shodan and look for, say, uh, type of vulnerabilities on my vendor's domain, for example, I'm just taking an example. I can see multiple vulnerabilities which are open, perhaps, and such kind of domains are to be kept in suspicious category. And but why? I have seen in my professional practice so far, lot of SMEs or lot of lot of SMEs have gone through a lot of attacks, uh, especially when they were in suspicious stage. If they were vulnerable, they get hijacked because of those vulnerabilities getting exploited, and then they become malicious because it actually becomes a bot base. That particular website or that particular domain itself starts sending attacks to different malicious parties or some clean sites as well. So it becomes malicious in turn. And what is, after all, a malicious domain? A malicious domain is like, which say, as Mukesh just explained us what a DGA is, for example, it talks to a, it generates a lot of domains, right? However, DGA is a separate topic, but she explained us, like, what a CNC is, how a malware could communicate with a CNC or command and control server, which could be hidden behind a domain resource. So a domain resource which hides CNC behind it, it would be categorized as malicious. Similarly, it could actually have a lot of resources or URLs which have phishing payloads or credential harvesting pages, which can actually, allure you to click it, log on, and then you lose your credentials and you're gone. So basically, it can also host a lot of malicious payload hosts. For example, movies, they are very alluring. People go download movies and they are gone. So they are all spywares at times. So these are malicious domains. And the fun is the risk states keep fluctuating. So that is the fun, and that is a challenge for a CTI specialist as well, because these keep changing. It's a dynamic data, it's a dynamic information. Today a domain is clean, tomorrow it could be suspicious, it could remain suspicious for 6 months, it could get into malicious state for a day, and it becomes clean. So uh, that is the story of domains. But now let's try to magnify a specific variant of domain which could actually lie in two states. Now this is virtual, that's not actually true, but so as to speak, if a domain which looked like google.com is clean today, but a domain which looked alike google.com could be malicious or suspicious, right? And a look alike is definitely more alluring for people to actually click on it. And that is where we actually go into the time space. We actually see that what is happening, and all these states are like, these are function of time. So basically we end up looking at what typo-scotted domains are. As we just spoke that, google.com and a google look alike, what is that? A Google lookalike is nothing but a typo-scotted domain of Google as a clean target. And as we see this infographic, these two clouds look similar, but yes, one of them may be owned by a hacker. Cool. So let's see what is typo-scotting. Typo-scotting is a phenomena of generating and registering, basically, similar looking domain names with respect to a pre-existing clean domain. Okay. uh, I'm happy.com, this is just an example. So it comes with a disclaimer: if it is a real site, I have nothing to do with it. I have not typo-scotted it with intentional malicious intentions, basically. So I'm happy.com, I'm happy.com. Oh, this A has been replaced with O. But if a hurried user looks at it, if a user who is not that security conscious could actually be allured to click this particular typo-scotted domain name. And yes, this happens quite a lot. And this is what is typo-scotting all about. So why is typo-scotting done? It is surely done for fun, yes, but there is more to it. Beyond fun, it is done for offensive reasons. Well, a typical hacker would register a typo-scot. He will or she will allure target to click on it or use it, and then basically victimize the target. And also there is one concept known as cyber squatting. Basically cyber squads usually sell back these domains to the targets and make dollars, right? They make money. So it's similar to the land acquisition principle. If I know that, okay, this particular land is going to be very much in demand, better to buy it today and then, sell it for uh, huge cost later on. Anyways, so basically this is why typo-scotting is done for offensive reason. There may be other reasons as well, but this is what I have mentioned here. And there could be defensive reasons as well. So if something can be done for offensive reason, why not do it for defensive reasons? That is how antibiotic works, right? So for defensive reasons, we generate typo-scots at in-house. I mean, an organization can actually generate typo-scot as if a hacker would do. It could do defensive blocking and do awareness to its vendors, suppliers, customers, etc. If it knows that there is a notorious typo squad that is alive and could pose a lot of risk to the business, yes, it is done. And there is a costly approach to towards very risky typo squatted domain names, that is known as defensive registration. We can actually go ahead and, I mean, the organizations can actually go ahead and register those typo squatted domain names, which could be very risky if they are in the hands of hacker. They actually go and register them. It is a costly affair because you have to pay for registrations, but yes, that is one of the defensive approaches. So let's look into what typo squatting common techniques would be. So basically, a hacker, or for defensive purposes, what could get you to a typo squatted domain name? For example purpose, I've actually used one of my blog spots. I mean, it's my musical band page, band blog. So nobody can come to me and say that, oh, you have used my domain. Cool. So let's take first example. It could be a misspelling, right? It could be a simple misspelling that can actually land you to typo squatting. See, just one R is missing and you have a typo squatted domain name. Then a TLD change. I think Mukesh also spoke about this. This TLD can actually just get flipped to co.jp from com, right? The top level domain name gets changed, and it is equally alluring for a hurried user or for a low security conscious user to actually visit this. However, the resource behind this particular domain could change, right? Then comes combo squatting. Combo squatting is not related with misspellings, but it is usually adding some kind of a meaningful word which lies with the context, or which matches with the context of what you're trying to typo squat. And here it is like rudder.musicblogspot.com, and it is also equally alluring for someone who knows that, okay, it's a music blog, and okay, fine, okay, I'll click it. Fine, cool. Then comes doppelganging. Doppelganging is all about playing with the dots, especially around the domains and subdomains. So basically, you just merge subdomains and domains, and you enter into a complete different domain, right? If you look into this, it was rudder.blogspot.com. So basically, it was, the actual domain was blogspot.com. However, now it is rudderblogspot.com. It is a completely different resource. Flips are used, so you can just keep playing with the dots here and there, and you actually end up getting a very different domain itself. And the funniest part, or the very interesting one of the attacks, is homograph attack. Homograph attack is like using some kind of other languages, or some Unicode characters from other languages, who actually look similar to your basic string, the initial string. Oh, I think I have copy pasted it. No, actually, it looks similar, but just for information, this O and this O is different. The Unicode value for this O and this O is different. However, it looks very same, and it is extremely difficult for a normal user to distinguish this. And what stops him to clicking from it, right? No, nothing stops. Let's also look into a few more examples into homograph attacks. So basically, google.com, right? It all looks well. No, this G and this G is different, and actually this is a Unicode representation of this domain. Thankfully, the DNS does not save this Unicode as is, but it actually goes to, I mean, it resolves it into a Unicode equivalent, which is this xn dash dash oogle, whatever. It's a random thing, which but it's a unique mapping. And basically, whenever I try to copy paste this or click on this on a browser, I'll actually end up going to this resource. And if we have a quick look at virus total, let's see what virus total tells me about this particular Punycode domain, basically. So this Punycode domain, according to virus total, okay, it says 3 detected URLs under this domain. We will not get into in depth of this, but I'm just trying to give you an example. So it gives me three detected URLs. So that means there are three malicious URLs already hosted on this resource. And a quick categorization from VirusTotal gives me it's not a recommended site, according to Dr. Web. And according to Force Point Threat Seeker, it is a park domain. Cool. So basically, something is fishy, right? Yeah, definitely it is. A similar example, WhatsApp.com, our near and dear WhatsApp, also looks the same, right? Of course, this looks a bit fishy to me, and I'm not sure because WhatsApp is used by so many people. Most of the people may not be security conscious, and they would be easily allured, made allured to actually click this. It actually resolves to, when actually we see what it resolves to, it resolves to this particular punycode resource. And when we check this, oh, 10 plus detected URLs under this domain. So basically, yes, there are so many malicious resources on this particular domain, and we know what that is used for. The categorization is still not giving any category. No problem. VirusTotal has to update that. Great. So let's have a quick look at what risks or what are the risk factors associated with typo squatted domain names. Why are they used actually? So malicious typo-squatted domain names can be used for alluring corporate employees, vendors, suppliers, customers to click and fall victim to hosted spyware, ransomware, etc. behind them. It could definitely be targeted reputation, financial, privacy, or operational risk to both the typoed enterprise and the victim. Yes, the suspicious one could be, I mean, there may not be a very clear intention open in the wild while they are dormant, but the CTI analyst or the CTI specialist or the CTI function has to keep a track of such suspicious domains because they have the most potential to get converted into malicious domains, and the window in which they actually convert from suspicious to malicious is not trapped in most of the feeds, the CTI, so-called CTI feeds that we get, because it takes time for the feeds to get upgraded as well. So there is another very interesting risk behind typo-squatted domain names, which I have seen the most in my uh, professional tenure so far, which is fraudulent. So basically, a lot of payment frauds. I mean, a lot of typo-squatted domain names are used for carrying out payment frauds. So basically, A sends email to B, B sends email to A. There is a C who impersonates B and starts sending email on the behalf of B to A, and then asks him to pay to some other place, and he runs away with the money. So such kind of payment frauds are easy to for carrying out for the hackers using typo-squatted domain names because they are lookalikes, right? Yes, there is reputation damage associated with this. There can be a lot of gripe sites and activism being carried out using typo-squatted domain names because they look alike, but then they start talking nonsense, or they start talking something bad in the public, which actually degrades the reputation of the target company, which is very bad. And later on, I mean, it's very easy to spread such kind of typo-squatted domain names, so one has to keep a track of that. And yes, I have seen some cases where it can be used for counterfeit product selling as well. So these are like some kind of we have already spoken about cyber squatting, but yes, it can be used for defensive purposes. It can be used for creating honeypots. I mean, if a hacker can actually place malicious payload behind a typo-squatted domain name, why not? We can put a honeypot, right? And yes, defensive domain registrations we have already spoken about. So time for poll one. I request your help, Mervin, on this one.
Yeah, just a minute. I am pulling up the poll question, and I will go through it and launching it right now. Very simple. The rules of the poll. So the question is right here. What is the top threat you have actually seen hitting your known surroundings, organizations, friends, etc. That may have used typo squatting as one of the key vectors. Now, the first option is phishing or for credential harvesting, spamming, payment frauds, spreading malware, and or others. Right. So, giving you a good amount of time to go ahead and read through the question again and read the options and select and choose whichever one. So yeah, and it's about, we are almost a minute in to the question. So, and I am about to end the polling in 3, 2, 1, and now I shall share the results. Hope everyone can see it, including Weber.
Cool. Thank you so much, Mervin, and thanks everyone for giving your valuable inputs for the poll. Cool. Yes, fishing for credential harvesting. Yes, yes, I've seen that as well, and I very much resonate with the audience poll. Okay, so I hope I'm audible again, and I shall
Yes,
start
yes.
back. Thank you. Cool. So we are done with the poll one, and we enter into what cyber threat intelligence is. Well, it's all about augmenting detection, response, protection, and investigations for the security frontliners and business as well, right? So, what could be the typical approaches in a cyber threat intelligence function? Uh, Traditionally, it's all about gathering data sets, filtering them. There's a lot of buzz about usability of the data and understanding the context of business. All these are buzzwords, and yes, these are right buzzwords in right direction. However, in practice, they are not that simple as said. So basically, first approach that we spoke about was retrospective approach, and as the name suggests, I mean, these are the distinctions made by myself. It is non. I mean, it's not taken from any textbook or any standard text out there, but this is out of my understanding so far. So basically, a retrospective approach is looking into the past. It could be a recent past, of course. It has to be recent past, and that is where the challenge is. How recent past you can actually have a look at, right? How quickly you can absorb information from the what is recent past. How do you define recent? Cool. So retrospective approach is about gathering data sets from the past and known, creating IOCs or extracting IOCs, and of course filtering them, prioritizing them, and making it more meaningful for your organization. Extracting TTPs, that is the techniques, tactics, and procedures, and then creating some sort of blacklists so that your security frontliners or SOC teams can actually work with them. It could be advisories as well, apart from blacklists. I've just written here blacklist, but that doesn't mean it just contains blacklists. It does contain advisories, it does contain metadata at times, it contains a lot many other things, but blacklists are usually quick actionable items that typically a SOC would actually place it on endpoint protection mechanisms or a SIEM tool to quickly see things in action, right? Blocking or detecting stuff. Now, there could be one more approach, or rather two more approaches: predictive and proactive. So these are very interrelated, so I have just mentioned them together, but we'll see how they may be different. But it's all about anticipation or forecasting the threats, right? Or techniques. It actually takes you from a paradigm of IOCs towards paradigm of IOAs, that is indicators of attack. So basically, you end up forecasting threats in some way, that okay, what could hit me, how could it hit me, and if it hits me, how would I look, right? And how would I stop, when would I stop it, if I won't be able to stop it, how do I respond to it, XYZ. And that, I consider this all things, I mean, these all things actually are part of cyber threat intelligence. And this can be accomplished to some extent, again, to some reasonable extent, using dynamic rule sets. One of the dynamic rule sets, okay, we will talk about it. So dynamic rule sets, it could be, definitely statistics is like, the mother of everything. beyond statistics, ML comes into picture, machine learning, as Mukesh has already introduced us with machine learning concepts. Machine learning comes into picture. NLP based, this is actually very specific to typos quoted domain names, because it talks about, it is related very closely with linguistics, and it is related very closely with string types. It's all about text, right? So quick look at a different way of looking at methodologies is retrospective is like looking at the past. Okay, learning from the past. Something has been notorious, okay, go and block it. Also monitor it. If you find it, let us know or respond to it. Predictive approach is like forecasting the future. Astrologers. Well, something could become a potential problem. Keep a watch. I say as a CTI function, block it. But no, the business needs it. What to do? It is not malicious as of today. I cannot block it. What to do? Okay, keep a watch. Well, if it hits me enough, block it now. So basically, it is like, forecasting the future. And proactive is like something that you constantly keep running. So be on the run, and when you're tired, of course, go for a tea break. And this proactive thing is really helpful for you to take more tea breaks than usual. That is what I have seen. So let's move ahead to look into it uh, more in a deeper way. So information flow. This is just a quick information flow. How does the information flow in a typical retrospective approach, where one hunts the past, uh, incidents, malwares, information, news feeds. So whatever is available, you are trying to dig stuff from it, and of course that is rich in information. You gather it, you extract whatever is necessary, you filter it, you prioritize it. You prioritize usually the footprints or IOCs, indicator of compromises, and pass it on to the SOC team or maybe business if you find, the IOCs are more business relevant apart from just giving it to the SOC. So the SOC would then block, monitor, detect threats, and a usual SecOps kind of a uh, procedure would run. There will be a response if at all a threat is detected. There will be a feedback to CTI function, and that is how we improve, right? Uh, just to mention, nothing is perfect, and so as CTI is never perfect. Actually, it is far from perfect, but it is striving to give some information always. So CTI is definitely never perfect. Retrospective methods usually are like, blacklisting and advisory, blocking, active detection response. So basically, it aids in blocking active detection and response. It could include IOCs, malicious, suspicious, leaked DGA lists. This is also very interesting, as Mukesh had already pointed out. Towards DG algorithms, yes, there are researchers who actually keep on leaking algorithms, right? From malware, for example, Naker's botnet. So Naker's algorithm, the DG algorithm, of course it can be changed, but all the variants that are out in the wild, the algorithms are reverse engineered, and basically they can be reprogrammed to actually generate similar looking domain names which a Nakers would actually generate. So basically all these things can be done, but here what I'm talking about is it's leaked DGA lists. So basically there are people who keep leaking DGA lists, the potential domain lists which actually a hacker could generate or the malware could generate. And historically malicious or risky domains is a very key thing in the context of business. And awareness and prioritization is also a part of retrospective method. Let's not go much into it. We will actually jump onto an interesting thing known as proactive or predictive approach. So this is like, now you have a retrospective approach already running in your CTI DevOps cycle or SecOps cycle. And okay, what else can we do? So basically, the way I have actually tried to mention here it is, the left part is more of a predictive approach and the right part is more of a proactive approach. Okay, so it all starts with digesting the context of your business. Like, who are your vendors, who are your suppliers, who are your customers, what domains you own, what regions do you play in, how you play in, what are your product portfolio, what are your products, what are your uh, product domains, if at all they have, and so on and so forth. So lot many data has to be digested first, and then you actually either do adversarial thinking. You actually try to build up methods that your adversary could build, and then you can generate possible footprints or IOCs or indicator of attacks, and then send them to the monitor and detection phase to the SOC team. And similarly, you can also use statistical or mathematical based or machine learning based approaches to actually generate signature logic. So now it is not about generating blacklists anymore or just IOCs anymore. Your logic actually ties up with your SOC team or SOC team's detection logic. It goes at that level and it stays there. The CTI team has to just keep tuning it, according to a few parameters. It could be machine learning based as well. And at times you have to actually, take a decision to retrain the model or not or whatever. So this tuning has to be done by the CTI expert. He or she can actually give a lot of inputs to such kind of a model, which actually ties very closely with SOX monitoring and detection capabilities, and then we have response and feedback. So theoretically, it all looks good, but we will try to see one of the approaches how we can actually accomplish this. This is definitely subject to customization. It depends from organization to organization what is best. So I am not trying to say that a specific thing is best or one size fits all kind of a situation. This is highly subject to customization, and yes, it requires a lot of persistent research and development in house. So it is not something that you go and just buy and start it in your organization. In my opinion, it has to be actually very closely related with how your business functions, how your teams are laid out, what is the structure, what products are you into, what category do you play in, etc, etc. So a quick look at what defensive typo squatting, predictive or proactive CTI methods could be. One is generative method, where which will employ in-house fuzzing, and it will actually give rise to creation of temporal blacklists of resolving fake domains. Now, resolving and fake domains is very important. Uh, this is a temporal blacklist, so it may stay for a day or two, practically speaking, and it will just contain, it may contain, okay, I mean, this is one of the examples, this can change from org to org, but this may contain only the resolving fake domains, okay, only the domains which are resolving today, that is the domains which are active today, are of the most interest to me. I mean, this is one of the ways of filtering data to make it more meaningful. Again, it all depends upon the context of your business, and also a lot of analysis can be done on the base of the domain age, and constant tracking of the dynamicity of the temporal blacklist over time is also very important, so that you arrive to a conclusion that, okay, for example, a typo squatted domain name came in January. Uh, it it was registered, then it actually went away. Then it became suspicious in March, and now uh, until December it was nowhere, and it suddenly popped up on 1st January, or maybe it suddenly popped up on 20th January, and looks like it is targeting to sending a phishing attack to someone, maybe within the organization, or maybe something else. So basically, one has to have a very close eye at this. Another generative technique could be DG algorithm harvesting and execution. So as Mukesh pointed out, we could have a lot of DG algorithms running for us in-house, and then they can actually help us creating temporal blacklists because they are time dependent. And then we can also do some kind of additional analysis after we actually generate these temporal blacklists, because we can do who is matching, we can do further analysis that who is actually trying to own such kind of domains. And of course, there is not just one technique here. We are talking about a number of techniques to be employed to there is a concept of diamond model in when we talk about CTI. So it all revolves around actually trying to find who the adversary is. We know what he is doing, what he's trying to do, what are the tactics, etc. But then we have to try to identify the adversary. And here is, I mean, by further analysis, I mean, we try to understand who could be the adversary. Anyways, well, we move on from generative to procedural ways, and one of the procedural way that I wanted to talk about today is using string matrix. String metric is a algorithm. We will talk about what exactly it is, but it gives me an opportunity to identify potential fakes. It gives me an opportunity to also peep into my insider threat. So insider threat behavior is not just malicious at times. It could be erroneous. It could be out of being a victim as well, right? An employee of an organization could become a victim. It could be victimized, and then we can see a lot of abnormal behavior coming in from that particular insider, or the employee could also be pointing us to an insider threat. However, we need to then go into the depth and try to investigate whether it is an insider threat for which reason. So anyways, this particular method can help me identifying insider threat for typo-scotted domain name. So please, I just want to make it very clear, this is just in the context of defensive typo-scotting, because these terms are like really huge and we can keep talking about them with different contexts. So and yes, string metric can help me building early detection indicators as well. So basically, this is how we actually go beyond blacklists, and it is the time for poll 2 before we actually delve deeper into what string metrics are. So requesting Mervin for pulling up
Yes.
poll 2.
Yes, definitely. So I'll pull up the poll to it's about a minute. I'll read out the question, and about a minute for people to look at the options and answer. Okay, so I'm launching the poll now. What is the best cyber threat intelligence approach in your opinion? Right. So based on your current organization landscape, to keep risk of domain typo squatting at bay. So feel free to answer. And what is the best cyber threat intelligence approach in your opinion to keep risk of domain typo squatting at bay? Okay, and I'm about to end the poll in 5, 4, 3, 2, 1. I've ended the poll, and now I'm about to share the results. So
Cool.
there's a little bit of a tough between proactive and mix or hybrid. So
Wonderful. And I again go with the audience poll here. Great, great, great input. Thanks everyone again, and thanks Mervin for this poll question.
yeah, no.
So shall I go ahead, Mervin?
Yes, please, yes.
Cool. Thank you so much. So, okay, best preferred. Yeah, so basically, hybrid was my answer as well. Yes, we all understand this because retrospective methods have their own advantages. Uh, Other methods like preventive and proactive definitely have their own advantages, and pros and cons are everywhere. So yes, hybrid method is always the best because we meet the best ends of both, and the goal is finally to strengthen the SOC and the business all, of course, thereby the EP mechanisms seem correlations to better detect and respond to threats and business requirements. So cool, we achieved that goal. Defensive typo squatting. Okay, so let's try to generate some intelligence beyond blacklists now. Okay, we'll look at two approaches here. One is domain name fuzzing and intelligence out of it. So what is domain name fuzzing? It is pretty straightforward actually. It is employing combinatorics and analytics basically to, so you have a clean target or clean list of targets. Okay, And the targets could be yourself as well. I mean, you may have a list of own domains, or list of your vendor domains, etc., this supplier domains, etc., and then you can actually start fuzzing them. Once you start fuzzing them, you can, of course, for fuzzing you can use some custom string fuzzers. I mean, people can write excellent fuzzers. There are some open source OSN tools available for fuzzing. We all know there are plenty of them, URL crazy or DNS twist, or a number of tools are there. Even burp suite has some fuzzing technique or feature within it. So there are a number of fuzzers actually that can be used for fuzzing a list out of you know uh, clean domains, clean list of domains. And then basically when we move from fuzzing into intelligence, it is more about checking for the resolutions. That is what I would do, right? There may be some other things like looking in for who is information, IP, resolving IP. Of course, if it resolves. If it doesn't resolve, I usually stop for that particular moment. Okay, now you can actually run such kind of algorithms practically every minute. But of course your processing power has to be that matching to that particular that load that you want to put on your algorithms or your implementations. So I would love to actually run such algorithms every minute, but of course it is not possible and it's not required also. So you can actually set some frequency in which you do this, and you keep checking for the resolutions. The trend itself explains a lot. The trend of resolutions also explains a lot about typo-squatted domain names, and that is my personal experience. Once they are once they get resolved, you can actually enter into further analysis like who is lookups, metadata lookup. Of course, if it is available to you, whatever is available to you, you can actually pull up Maltego to actually try doing some kind of correlations around your IOCs that you already have. You can actually pull up another other tools to further fuzz it. You can actually have a look at IPs. You can actually do some ASN analysis, etc., etc., etc. So there are so many type of intelligence that you can gather out of it, and then you can actually give it to the SOC in a usable way, because we have to make the information usable, right? After all. So this does not just go to SOC, it actually goes to the business as well, because we can see a very different trend at times that okay, some kind of domain is acting, trying to act very notoriously. It keeps coming, it keeps going, and then it stays, and it tries to host some kind of activism information, for example, all of a sudden. Or it could be a gripe site which talks bad about your business, for example. So yeah, it very much happens in certain sectors like banking, or it could happen in especially in FMCG or pharma or agrochemical, etc., etc. So such sectors are very much prone to seeing such kind of notoriety going on with typosquatted domain names. Now, just as I said, one could write custom string fuzzers, which is great in my opinion. Writing your tools is always great because you know what you have to do with it. So these are a few fuzzing considerations, some key fuzzing considerations that you may want to have while writing your own fuzzers. So basically, these are few techniques that you may want your fuzzer to have. So you may want to have more, but this is what I have collected. So it could have character omission, it could have strip dashes, it could have missing dots, and the best part is I'm not going to read all of this, but you can see a few examples. For example, if I take character omission, it is like just omission of one character. Now you can actually start combining these. So for example, if you have homophones, so homophones are like two strings which sound similar, right? So or you have homoglyphs which look similar but they are different. So just by looking at it, you may fall into the trap that oh, it is google.com, but it is GOOG1E. So you can start combining these techniques together as well. Like you can have one character omitted and one homoglyph prepared. So basically, one homoglyph with one character omission would give you another combination. So there are plenty of more combinations that you can generate, but these are a few key fuzzing considerations that I have compiled. I'll give a 2-second break on this one. Uh, you may go through it, and if it's okay, we will go ahead. Now, let's try to add some groove to this music that we have tried making so far. Hackers still come up with something very unique, right? I mean, I have used fuzzing techniques or defensive fuzzing techniques quite a lot, and I have seen hackers still come up with something very unique, just with a slight change, and you tend to miss them out of your logs, or you tend to miss that particular thing from detection. So what else can be done? Uh, this infographic is a bit funny. I just compiled it with some intention. Uh, you can have a lot of money, right? You can just keep buying a lot of tools and which can promise you to do this for you. It can add a groove as we do it in music. We can have a lot of drum composers and then we can have a lot of nice drumming. But but that may not really suffice. Or you could run away, just pick up a bike and run away. No, no. You can actually design your own solution using something known as string metric. Let's go into it. Before looking at what a string metric is, I just tried compiling this slide where I have two instruments kept along the slide, and the question is how far are they placed? Okay. From CTI perspective, however, the question is I have two strings. One is PIANO and other spells like GUITAR. How far are the strings? So I had a few bots. Okay, I'll ask those bots what is the answer. The first bot is very intelligent. Let's see what it responds. It says don't know. Amazing answer. Okay, non-reliable and rather very reliable. Don't know is most reliable answer. Okay, cool. We'll move to the next bot. It says it is not too close. The strings are not too close. Okay. The next bot says it is too far. The strings are too far. They are too far away. What should I do? Okay, it's not usable information still as yet. The last bot says these are 2 kilometers apart. Oh, cool. It has a capability of quantization or quantifying this particular answer. Cool. Let's ask similar question once more to these bots. Now I have different set of instruments, or from CTI perspective I have two different kind of strings here. One string reads as keytar, KEYTAR, and another is GUITAR. And in musical world, yes, guitar is there. It looks similar to guitar, but has keyboard. So how far are these strings, guitar versus guitar? Okay, my first bot, I'm sure it is going to be more intelligent this time. Oh, it says don't know. Fine, most reliable. The second bot says bit close. Okay, so it starts understanding it is getting closer. The third bot says not too far. And my fourth bot, as usual, gives me a very honest and very nice answer, a quantified answer that is 1 kilometer. So, fun apart, jokes apart, if we look into these two examples, we can see there is a way which can be employed for giving me a quantifiable answer to this question. That is how far are two strings. Okay, and this is very useful. This is called as string metric. A string metric is nothing but an algorithm that quantifies the distance between two strings. Okay, this is done employing various algorithms. We'll talk about them in the next slide. But by some magic, it actually gives me a quantification. We'll see what the magic is. And a metric typically should be a quantifiable output. It has to give me a quantifiable output. It has to be reliable, of course. It should not change every day or every time I ask it, and it should be scalable, right? Any length of string I uh, give to it, it should give me a good answer, reliable answer, specific answer. And when something is quantifiable, it is measurable, and what is measurable is manageable, right? So let's look into a few algorithms that can actually give me a string metric, or which can help me deriving string metric. Now, string metric is also not a straightforward process. Uh, in this slide, actually, this etc etc should have been much bigger than these algorithm names, because there are plenty of more algorithms apart from what I have noted here. But this is just for the sake of presentation here. This is a highly research oriented topic. It is actually string metric also comes from NLP world, because it's all about linguistics and how close the strings are. It is also used for recommender systems, to be specific. So anyways, one of the algorithms could be edit based. So there are two algorithms that I have mentioned here, Levenstein and Damaro Levenstein. These were the scientists who actually gave the algorithm. So edit based is like, how many edits do you need to make to the first string to reach to another string. So basically it is called edit based algorithm, edit based string metric algorithm. Token based could be based on the tokens in a specific string, and then the tokens are actually extracted in terms of their occurrences, and then the algorithm is applied. So it is like it is plotted onto a XY graph, and then a lot of statistics gets applied. Then there are sequence based algorithms. So it actually takes a LCM of how many common occurring tokens are there in two strings, and then it goes from there. There are compression based algorithms. There are phonetic based algorithms, and phonetic is again same, which sounds same, right? So editix and MRA actually could give me some distances between two strings based on their phonetic characteristics. And then there are parameter based algorithms, which are simple parameters like prefixes, postfixes, length distances, matrix stability. So matrix stability is all about, the strings are actually plotted onto a matrix, and then the distances are calculated using some matrices and calculations around them. So again, as I said, etc should have been bigger, because there are plenty more algorithms, and this field is like going crazy. It is a divergent field, so to speak. So well, I'm happy now. Let's take a closer look at the distances through this snippet. This is just a snapshot of my Linux screen, where I have just tried to invoke Python, and I've defined 5 strings here, as you can see. I am happy.com, I am happy.com, a variant of it where I is replaced with L, and I am happy.com. So you can see these variants. And the last one is I'm not sad.com, which is semantically same to A. I mean, the meaning is similar, but they are not same. Editorially they are not same, so they are just semantically same. Now I'll try to feed these strings into my Damarul Levenstein distance algorithm. Okay, so this distance lib could be any of your libraries that actually have these capabilities, and you can even tweak them. You can override them, etc. I mean, let's not go into that, but yeah, you can actually have one of the libraries tuned according to your requirements, and this is one of the libraries that I have tuned to my requirements. So I have used Damaru Levenstein distance algorithm on A versus A. So basically A and A is same, of course, so the answer is 0. So they have no distance, I mean, they are like same. If I actually trigger it with A comma B, then it gives me 1. So basically only one edit in A gives me B. Similarly for A to C, similarly for A to D, 1 1 1. And if I give A to E, it gives me 6. Cool. So it is something measurable, right? And it is very interesting because I can actually make out a lot out of it. Let's see how. So, of course, the Meru-Lowenstein algorithm is not around semantic uh, comparisons. Therefore, it will purely give me edit-based distance, and therefore it gave me 6. So basically, according to this algorithm, it will need me minimum 6 edits if I start with A to reach E. So they are distant. Okay, cool. Now we are like going up the ladder onto our outline, and we are into example detection workflow prototypes. So based on whatever we have discussed so far, We will look into one of the detection workflows, first prototype that I would like to present. Uh, Please consider this first part is like unique list of email senders at a set frequency. Okay, you are getting a unique list of email senders from or to your organization. This can be actually coming from typical email gateway logs, or maybe cloud logs, or whatever you have in your organization. You can actually pull up those logs. Now these logs will contain, so I'll make sure I'll filter these logs in a way that it just contains a list of unique email sender domains. Okay, by email senders I don't mean the full email addresses here for this particular example. It is just email sender domains. Okay, from and to. So you can assume any one of the scenarios. Then I will feed this into my intralist similarity detection using string metric algorithm. So now here I do not have any blacklist. Okay, I do not have any blacklist. I do not have any CTI feed. I do not have anything till this moment. What I'm going to do is I'm just going to take this list and traverse through it, and I'm going to actually do an intralist similarity detection using string metric algorithm. I'll then analyze lowest distant domains, okay, with some filtration, of course, with some kind of tuning, of course. And then if I find any, then I'll actually push it into a retrospective check. This is optional, but yes, ideally I would like to do a retrospective check as well on the data that we gathered out of this approach. And then I would like to trigger a condition based alert to my SOC or business or whatever. So let's have a DNIF run the detection. Okay, we will have a running model. We'll see a query running on DNIF console itself. I'll just walk you through what we are going to do in that. So we will create a dummy list of domains that I have already created, as if they were extracted from raw log sources like email gateway web proxies. Okay, using DNIF custom profile store feature. So this is what I'm going to do. Then I'm going to actually run a custom self-programmed ML module to execute select string metric algorithms. Okay. Again, as Mukesh had advised, I'm going to use underscore ML directive in DNF, which actually gives a very flexible feature for me to invoke my own modules, right? And this is my own module, so I will be triggering it using underscore ML, and then I'll be applying some filters. So here is where you tune your outcome. Okay, so basically I'll be using check if directive of DNF, and then as we actually saw in the previous slide, we'll run it through some kind of retrospective check. Or so basically we are going to use virus total. This is an optional step, but we are going to do this, and of course using a lookup directive in DNF, and then we will examine the output and further possibilities. Okay, so before we get into another prototype, I would like to share my screen with the DNF console. Please give me a moment. uh, Mervin, could you please tell me if the screen is visible? Hello? 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 Mervin, are you there? Okay, I assume the screen is visible. Okay, and we are on the DNF console now. So, okay, I'll just quickly check whether it is up and running. Cool. So, oh, my session has expired. Give me a moment, please.
Hello, Vaibhav. Sorry, we were having some technical difficulty. Yeah, please tell me.
Okay, just wanted to check, Mervin, if I'm audible and my screen is visible. I mean, the DNF
Yes,
console
your
is
screen
visible.
is visible. We can see the console. Yes.
Great, wonderful. Thank you so much. Cool. So my session had expired, so I'm just logging in again, and I'm on the DNF console now. Cool. So, uh, let's go. Okay. So basically, at the start, as we said, we will actually have a dummy list with us. I'm not going to play with any corporate data here for the sake of privacy reasons and confidentiality. I'll just create some kind of dummy data. So I have actually created some dummy data using into my test profile. So this is the test package. I have actually created this test domain list. Okay, it's a entity type profile. If I were to show you uh, what it is like, so I've just selected a file. I've loaded a few domains in a file. I've selected it, uh, kept the profile function as stack append, and I've just loaded the list here. So it has some test domain test domains basically. So you can see a few, imaginary domains are placed here, and there are some examples which look alike. Okay, guitar.com, rudder.com, rurer.com, google.com, and so on and so forth. So let's try to play with it. I'm on the console now. Okay, and I would like to retrieve to start with pulling up the data. Test domain list. Okay, this command will give me a list of all the domains that I have in my list. Okay, now uh, as I don't have any ready-made feature, I have actually made one of my modules which will calculate the intralist distances. Okay, and the name is vxtx3. The module name is vxtx3. You can name it anything. I mean, it's my choice. So vxtx3, and the function name is intralist distance scan. This function has been created by me. Okay, and I want to operate this on this particular uh, field. So I give it test domain, and so basically typically underscore ml directive takes two arguments, and another argument should be I don't have any other argument, so it will be just a dummy argument, and I'll just run this. Okay, so as you can see, what I've done is I just had a list. Okay, I started with a list of the domains which are, say, sending emails to me, and I just first them within and tried to calculate distances between the combinations. So you can see these are 110 combinations generated out of 11 rows. Okay, now it is a lot of data. Let's try to narrow it down by using checkif in compare, because we have some integer values here. I would like to first put some kind of a comparison on, say, distance phone. So I'll just try to explain. This is there are three algorithms which have been implemented in my function, the intra list distance scan by me, and these are the three different algorithms which I have implemented. One is edit based algorithm, which is Dameru-Levenstein, as I had already spoken about. Then distance phone is like phonetic distance algorithm. I think I have used editx for this one. And distance token is like token based algorithm, which I have used as Jacquard algorithm. So I think I will actually put some kind of a filter on phonetic distances less than 6, and I'll only include those results. Okay, because I don't want the domains which sound very dissimilar to come into my further analytics. Cool. So you can see, uh, you know, they are sounding quite similar, right? I'm happy, I'm not happy. Of course, it has phonetic distance as 5, but okay, this is like a randomly chosen, empirically chosen number, which you can keep changing. Okay. Now, I would like to add one more filter to this. I'll say in compare, and I'll go on to distance edit. Distance edit. Okay. And I think I will Greater than 2. Okay, so let's exclude all the values for which, all the rows for which the edit distance or the Damerul-Levenstein distances are greater than 2. Let's exclude them, and we will actually have something very narrowed down for our further analysis. Cool. So I get in this data set, I get a combination of rudder.com look similar, but they are different, right? RURERR, RURRER. And I also get this pair Google.c, Google.com versus Google.com, right? So now I have something narrowed down for my further analysis. I'll uh, okay, so I would like to first clear out this uh, above data, which is now enough for me to go ahead. So I'll just put aggregate directive and say count unique, and I'll put it on test domain 1. Okay, so that will give me just a list of final domains that I need to now concentrate on. Okay, now, sorry. Okay, so this is the output, right? I have rudder.com, google.com, redred.com, and google.com. So these are the contenders, out of which a few could be bad, which few could be good, all could be good, all could be bad. Okay, so let's try to pull in some retrospective approach here. I will trigger a lookup on virus total on say get domain report on test domain 1. Fine. So what it will do is it will just take each value of this test domain and try to bring out virus total results for these domains. Okay. Before I run this, uh, because running this again and again may take some time, so let's also think a bit ahead. Before I run this, I would like to actually put in some filters there as well. So say check if uh, I would do an int compare, sorry, int compare uh, VT response code. I guess the syntax is correct, is greater than 0 and root. So usually what happens is, because I know if I run this query, I'm going to get virus total results, and one of the topmost or one of the key fields that it returns is VT response code. So basically VT response code tells me if it is 0, then virus total did not have this information about this particular query domain, and if it is greater than 0, that is typically it is 1. So that means it had the information and it will give out the information, right? So I'll only include those data sets where virus total could find the information. Now, actually speaking, we can have both cases. I can actually have a case where virus total gives me some data versus virus total doesn't give me any data. Okay, both are equally valuable for me. But let's take first example first, and then I will also similarly uh, put one more check if lookup where in compare VT reputation safety score is less than 100 include. So basically it is another field given out by virus total, and typically this particular score tells me the worth of, or the safety score of this particular resource that I'm trying to check on virus total. So if it is 100, it is typically good. If it is less than 100, yes, it could land up into suspicious buckets or malicious buckets, right? And for you know for further processing, I'll just add a field directive with say field name as alert of type string, and I will say malicious domain found, which I can then raise maybe to my SOC team, or I can actually trigger an email out of it. We will see that later, but let's run this pipeline. This is quite a big pipeline now. Let's run this. So it will run one by one. Okay, F1, F2, F3, F4, F5, F6, F7, F8, and F9. Cool. So using this pipeline, I end up having this google.com flagged as phishing and other fraud domain category, and this alert will then go to my SOC team by just using a raise notify email, and I can then just give a email, right, or anything. I can use just some DL here, or typically I can raise a module, or I can do a number of things beyond this. So basically what we saw was using just the input data set without using any comparison with huge blacklists which are processing heavy. We just compared the input itself to derive potential potential glitchy domains, okay, these domains, and then we just did a retrospective check on these, out of which I found one of the domains which was uh, phishing and other fraud domains which has a safety score of 70, right? So this definitely is something fishy, and then I have to take a response. But as I said earlier, what if virus total doesn't give me anything? It is also equally important for us to understand. No problem if it doesn't give anything. It takes us to some other some other analysis or other conclusions basically. So what I would do is I would just try to exclude this. Okay, if the virus total response code is greater than 0, just exclude it. So I'll only in turn include whatever virus total doesn't have. And then what I'll do is I'll try to actually again put a aggregate, or yeah, just for this purpose. And I can actually add a field as well, which is which says domains of interest. Okay, it has started running. I hope virus total API works here. Cool. It had work, and it has given me rudder.com versus rudder.com. So typically these these lists will be smaller, and it will actually go to the uh, SOC team or some other team with a field alert of type string, and I can actually name it as domain of interest. Okay, and then I can run, and then basically it will just give me some domains of interests. So, and then I can actually manually do something, either put it into a suspicious list where I need to keep a watch on that, or probably I can run it through some whois lookup, or then I actually run it through a number of other lookups to make more more conclusions out of that. I also would like to show you such kind of queries can be also okay, I will just go to the test package. Such kind of queries can easily be put into a workbook, right? So first type, I can keep adding queries here. So I'll put first type of query using virus total, without using virus total, and then I can actually run it on some cron timing, and basically I can actually keep triggering data out of it to my SOC team, which will keep them updated with what is going on. Then we can keep creating trend analysis. We can do a number of stuff using such kind of data. So I would like to go back to my slide now. I hope this was useful. Mm, Not sure whether the slide is visible, but I'll just try to. So is the slide available now on the
Yes,
screen?
yes, the
Cool.
slide. Yes, the slide is available.
Great. Thank you, Marvin. So we are like about to end this. This is just a detection workflow prototype 2, where, oh, my bad, sorry. Okay. So here, I just try to introduce one more concept from prototype 1. I just try to add a whitelist of own domains, suppliers, vendors, etc. And what I do is this list remains the same, a unique list of email senders at a set frequency. What I do is I compare it with a whitelist of known domains. Okay. and then I do further analysis and categorization based on this whitelist. So I'm more targeted now. I'm more targeted in terms of what I'm looking towards, what I'm trying to compare my data with, and what kind of threats I'm trying to detect. So this is like, hand in hand detection, or rather hand in hand CTI, hand in hand with SOC detection capabilities, to actually make them have threats in time, you know, to respond to, or to handle them in a better way. And of course, there will be a condition based alerting to the business or to SOC or to any specific uh, any specific other team that may require this. So basically, with this, I come to the concluding slide for today. I thank you everyone for patiently listening and being with me towards for this presentation. And the award goes to you. Thank you so much, guys. Over to Mervin.
Thank you very much, Vaibhav. I mean, the amount of information you've provided to us really is worth taking a look at again. There's so much information that you have actually provided to us at this point in time. So, getting back to a few things that we you mentioned, like if we can actually, I believe there are a few questions that have been raised at that point in time. Um, Going through them, if you'd like to get them answered live, you can answer them live if you want to, or we can obviously you can obviously type the answers, and or we can answer these questions offline. uh, Weber, so the question is on to you. How would you like to take this forward?
Hey, am I audible? Sure. I'm actually
Yes.
trying to type answers for a few, so I'm
Okay.
already taking them in. Yeah.
Okay.
And
Okay.
if time doesn't permit, I can actually offline answer them. But they are all are great questions, and thanks a lot for the questions again.
Great. 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 So yeah, we'll take the time. Okay, and go ahead and answer the questions. So just give me a minute. Yeah, the so we'd like to move forward, and there's one aspect that we would like to thank. We would like to thank Virus Total for being a session contributor in this. They've been very helpful in providing us with a lot of assistance in many ways, right? And I would like to thank Virus Total very much for this. That being said, and all of that information, remember, just like Vaibhav Tole, you as well, any one of the community members can be a part of Connect and become a Connect community hero. All they need to do is write to us at connect@nif.it and let us know, their name, what cybersecurity topic they would like to talk about, and just give us a small brief, and we'd be more than happy to get in touch with you and speak, and give you a chance to present on the next Connect, right? And do remember that if you are selected and if you get a chance to present on NIF Connect, you are assured a chance of winning an Amazon gift voucher worth rupees 1,000. So that's a great opportunity right over there, right? So yeah, one of the topics I'm very passionate about is don't be a desk potato, right? So I know many of us are sitting on our desks, not moving. We need to stay active. We need to keep active. We need to eat right, work out, stay active. Which leads to a healthy lifestyle. A lot of sitting on the desk and just not moving around. I know there's a lot of work. Sometimes we are not able to focus, but take that 2 minutes, stretch at your desk. If not, just have a walk. And remember, if you feel the hunger pangs, eat healthy and also include a little workout into your daily regime. Very important, right? And yeah, okay. So Weber, before I put add the closing word of thanks, just wanted to know if you still need some more time in regards to the questions.
Hey, yes, I'm actually typing the answers, so I may need some time.
Okay. Okay, okay, no issues, no issues. So just as I mentioned earlier, the entire session is obviously available on YouTube, so you can go at any time and at any point in time and watch it. We also, what we do is post connect, we take the entire video and we break up the sessions, right? So Mukesh session will be available as UEBA part 1. Vaibhav's session will be available separately, and even if you want to refer to any of the previous connect sessions that happened, you would like to view that in its wholesome, that is possible. If you'd like to view it segregated, like very specific sessions, this could be from Mikhail, this could be from NJ. Mikhail is from Kaspersky, NJ from BFeeds, if it could be from Srinivas from NetMagic, or Ankit Wasnik from Qualis. All of this is very much possible. It's all available. The content is there. It can be shared. You can obviously go if you have, if during the process of viewing these sessions you have any questions very specific to a particular presenter, you can write to us. Even now, you can write to us on stack.nif.it or write to us at connect@nif.it, and we would be more than happy to take that question and address it to the right speaker so that they have an opportunity to answer those questions. Right? All the forum is always open. The community is always open. We are open to feedback at any point in time. If you'd if you have any feedback for us, if you have any suggestions for us on, as to how do we improve the format, and get that information or get that knowledge out to people, we're more than happy to take that constructive information from you. Right. So also would like to bring to everyone's notice that we're taking a bit of hiatus in the terms of how soon we come up with Connect. Right. So the next Connect will be somewhere in the mid of March, where we'll have more than enough time to build on more content, build on maybe 2 or 3 presenters, depending on a presenter's availability. Obviously, there's a lot of thanks that needs to go out to some of the people at the back end that we do not know about from the Team Connect, right? So there's a lot of running around. There's a lot of back and forth in terms of how we gather all this information, how we approach our presenters, and how we sit together and we understand as to what the content is. There's a lot of curation in that. There's a lot of post work that happens in very short, and the contribution the team has to that also doesn't go without saying. It's very commendable, and it's really appreciated. There's a lot of people that work in the background to make this happen. Everything from the slides, everything from the videos that we see, everything from the the artwork, and a lot of constructive criticism goes into that. So yeah, thanking everyone, each and every one of them from Team Connect. Oh wow! So it seems that was really fast, Vaibhav. So I think we've
Thanks,
answered
Norman.
all questions, right?
Yes. Thank you.
Okay, great. So yeah, so that just leaves it up for me to thank Vaibhav and thank Mukesh for for that great presentation and contribution towards the Connect community. I already thanked the Connect team, which is very important aspect of me actually going ahead and presenting all of this. So it's very important. Thanks to them, each and every one of them. I wouldn't want to name you all, but I will in the next Connect. Definitely, I'll put each and everyone's name down so that I remember that all of you have been contributing towards this in your own very special way. Thanks to all our community members for their continued patronage towards Connect. Very important. Remember that there is no community without you. So till our next session, stay fit, eat healthy, have fun, and good evening.